Okay, hello, my name is Paweł Mastalerz,
I'm Wojtek.
and we are a DevOps engineer at Brainly, and we want to show you how our journey looks like to build a new infrastructure. So, short plan. First, I will tell you a few words about our company. Next, I will tell you about our current setup. Then we will tell about service-oriented architecture and microservices. Then we will tell about idea how to build a new infrastructure. After that, we'll tell you how we do this. And on the end, we'll give you some short summary. Okay, so Brainly. Brainly is the world's largest social learning platform. In other words, we can say we are some kind of Stack Overflow for students. We hit 60 million monthly unique users. These users view 360 million page view per month. And on the peak traffic, we hit almost 4,000 requests per second. So to handle this traffic, we have our current infrastructure, which basically runs on the dedicated servers. We have more than 100 dedicated servers located in Germany. We're using Linux containers. It's our way to separate some parts of the infrastructure. We have more than 800 right now. On the peak traffic, we have almost 700 megabits per second. We are using a typical LAMP stack, and most of the parts is automated by Ansible. So, what is the good side of current setup? Well, basically, it's low cost, because dedicated servers are a very cheap solution right now. We can use full power of these servers, because it's not shared with anyone. And we have also good community support, because this LAMP stack is basically most popular. Okay, but what is the bad side? Well, we need to take care about many unnecessary things like hardware maintenance, network maintenance. This infrastructure is designed basically only to LAMP stack. Also, we have monolithic applications, so basically it's very fragile to network stability. And as our company is growing very fast, scaling up dedicated servers can be slow.
So with the monolithic application, we decided that we need something else, and we decided to give service-oriented architecture a try. And you ask why service-oriented architecture? Because it allowed us to create simple services that are focused on only one business capability, and they can be developed independently by different product teams, and they can choose whatever programming language they want and use whatever toolset they want. And also it allowed us to decentralize data management, since the monolithic application is using only one database, and it's growing very, very fast, and it's currently very large. And it's MySQL, so it's very hard to scale. And with SOA, you can get multiple small databases, which is very easy to manage. And one of the ways to approach service-oriented architecture are microservices, because you can get this small code base of each service. So when a new developer comes, it's easy for him to just jump in and start working on the features that the microservice implements. And the microservices also provide us some kind of isolation, because each of them is running on a separate process, which is very nice if you want to containerize that. And with this approach, we also decided that we need a new platform, because the current one was not able to run any of the microservices or service-oriented architecture. So we decided to sit down and think about how to create a new platform that will run these microservices. First idea that we came up with is as infrastructure as a code. It means that we wanted the infrastructure to be defined in DSL, which is a domain-specific language. Tools like Terraform or Ansible can do that. It allowed us that developers were able to understand the infrastructure better and make changes on their own. we could document it better because it's a code. So even with some poor documentation, by just reading the code, you can understand what's happening. And thanks to that, we could also push changes to a pull request and review them in a traditional way, like in normal development cycles. Next idea that we came up with is immutability. It means that there's no live provisioning happening on the servers, and they're all deployed from pre-built images. Why we decided for immutability? As Paweł said, we are using Ansible on the current infrastructure, and with these hundreds of Linux containers, it just simply does not scale. Sometimes we had to do a few runs to configure everything. It was very error prone. We had this network connection, so it just failed randomly. And it led us in the state that the machine was not fully configured, some services were not restarted, and it was causing very hard to solve problems sometimes. Also, the immutability gave us the confidence that there are no changes happening on the server where they are running. So even every small change that we implement to the infrastructure, we have to deploy a new set of servers and replace the old ones one by one. We also wanted the infrastructure to be scalable. So problems with dedicated servers hosted with our hosting providers that we have to order them manually, and it sometimes takes up to 2 days for them to deliver. So scaling is basically very, very slow. And a solution that we said that it could be cloud, because with cloud you can add more servers when they are needed and easily dispose them when you don't need them. And you can apply some auto-scaling like you have on Amazon. Also, the platform should be fault tolerant. It means that failure of the server should not affect the system or end users. They should not know about this. And even the system should survive the failure of entire data center or zone in Amazon. Sorry. Thanks to the immutability, we could easily fix the problem with the server by just dumping the state of the machine at the time of failure and just replace it with a completely new one and just dispose the old one. Also, we need to be language agnostic so we could develop faster, because PHP was not enough for us. We should be able to choose the language based on whether we need speed, some easy concurrency, or just some specific set of a language or library. Okay.
Okay, so now when you know what problems we have and our idea how to change it, I will tell you how we make this concept alive. Okay, so the first part, what we need to change, it was replace bare metal servers with some clouds. And it was pretty obvious choice because, as I said before, we don't want to take care about hardware failures or network failures. And basically, any cloud provider don't have these problems. Also, second important thing is that with cloud, we have a very good security layer, because out of the box, we have isolated private network, also some security groups. With cloud, we also have solutions like load balancers, high availability databases. And also, in cloud, you can easily add more or remove instances, and that's why costs can be very elastic. So next thing we want to use, it's mesos. Basically, mesos, it's a very popular application right now to create a big supercomputer, basically cluster, to have good utilization of resources of each node. Mesos can be easy scaling, and it's also taking care of all cluster management. So it's high availability, and we don't need to care about this. And also Mesos is production proven at massive scale, because Apple, Airbnb, it's using it on production. Next thing you want on our setup, it's some init system for the mesos. And Marathon was the best option for this. Basically, it's treat application as a task. It's taking care of deploying restarts and also health checking with HTTP or TCP checks. So Marathon is taking care that each task will be always running. With microservices, we need also some service discovery, because services need to know about our current structure. And we use consul. Basically, because it has multi-data center support, also have a built-in health check. And also, it's working very well with Nginx, which are gateway to the outside world, with the tool called consul template. Of course, for the container, we choose Docker. First, because it's language agnostic, so developer can easily choose any language. And also, it's natively supported by Mesos and Marathon. Also, Docker isolate process from other instances and works well with consul thanks to registrators. So if some state of the Docker will be changed, then the registrator will know it and will inform consul. And then a consul template will reconfigure our Nginx. Okay, so here's how it's work together. We have Mesos and Marathon, Mesos master and Marathon cluster, which is high availability. On the Mesos slaves, Docker are running, and so you can see it's work with consul and our Nginx gateway.
Okay, so we have a container for our application, which is Docker, and we have a place to run this Dockers, which is Mesos, and we need some kind of way to communicate the applications to each other. We decided that we want asynchronous communication, and RabbitMQ was our choice for that. Why Rabbit? Because thanks to a plugin we found on GitHub and tweaked it a little bit, it allowed us to use consul as a service discovery, so it could cluster itself automatically. So we made RabbitMQ immutable also, like the rest of the infrastructure. This way, it's easy scalable. So we just create a new node from a pre-built image, and it's automatically added to the cluster. And thanks to the AMQP protocol, it's very wide supported by multiple languages and other applications. How it wires up with the core that Paweł showed you last time. You can see that one of the RabbitMQ nodes sends a request to the consul to register him. Then when other Rabbit node comes, it also registers in the cluster to the consul. And both of the RabbitMQ nodes fetches the list of other hosts in the cluster and just reconfigure itself to talk with each other. And we put an elastic load balancer in front of the RabbitMQ nodes so that the application could just connect without knowing how many hosts there are in the backend.
Okay, so we have running platform, but we need to have some solution how we deploy application to this. So we decided to use Ansible Tower, and I will show you how this process looks in our company. Okay, so when developer makes some changes, he will merge it to the master repository. Then Git webhook will send a request to our microservice, which will handle this. After this microservice will receive this notification, then it's sent event to our database. After this, there is another microservice which are listening for this kind of event. After he receives this microservice will talk with Ansible Tower to start build a new application. Then Ansible Tower will use his worker to build application image. And after build is successful, he will talk with Marathon and start this application based on deploy declaration. So what is deploy declaration? Basically, it's our solution to have common configuration for each microservice. And deploy declaration is basically a simple YAML file. And it's in cloud informations like resource for a single instance, minimum number of instances what should be running, and variables and secrets, and also before, after deployment scripts, for example, database migration. It's loaded and processed by Ansible, and also for the secrets we are using Ansible Vault, so it's injected during deployment. Here is some example of this deploy declaration. So, sorry. As you can see, we will run 5 instances. This microservice will be public. It will use low CPU purity. Each instance will use 64 megabytes of RAM. And here's some environment. So here we have address for our RabbitMQ database and some API key to the Algolia. Okay, so with microservices and so distributed stack, we need a place, centralized place where we will keep our logs. So also obvious choice was Elastic Logstash Kibana stack, because it's very popular and basically it's fit our needs. We also have set up it as immutable. And for this, we use nice plugin called AC2 Discovery plugin, which basically discover all instances running on cloud with typed tag. And for now, we are processing 100 gigabytes logs per day. Okay, we also need some good monitoring for our this stack. And we decided to use Influx data solution. So it's in Cloud's Telegraph, which is a tool that is it's collecting metrics from the instances, and it's sent to the Influx DB, which store this data. We track resources for each microservice, like CPU, memory, network, and events in the database. We also gathering all needed stuff from all our core instances, like mesos master, mesos slaves, and we visualize all this data on Grafana. So here's some example. Here we can see what is CPU usage for one of our microservices.
Okay, so with all this monitoring and logs, centralized logging, we need some kind of alerting for the microservices. So we also decided for our custom solution. So we decided that each developer should be responsible for defining a contract under which the service will be monitored and alerted. And we decided that the file will be stored with the repository with the name .sla. And here's the example of that file. Since we can see that the developer should define what's the maximum tolerated response time of the service, what should be the time window that will be measured. The same goes for 500s, how many we can tolerate, and how we can react on logs if some like panics occur or errors, warnings, like that. We should also define who and how should be notified about the problems. You can see that there's an example with Slack. We also support email notifications. Okay, so now it's time for some summary about the platform. Currently, we have about 28 microservices running on our platform. They are spawned in 72 instances and consume about 18 gigabytes of memory and utilize about 60% of CPU power of entire Mesos cluster. And the deploy pipeline that Paweł showed you, it allows us to deploy a single service in about 30 seconds since the merge to the master branch. And what are the benefits for developers after we created this platform? So we simplified the deployment pipeline compared to the current infrastructure. The developer only has to create a repository, then just works on some code, push it to the master, and the platform will do everything for him. We have created this way an entire set of Dockerized services for the machine learning purposes. And we have also an OCR services written in Go and Python. So you can see we can connect multiple languages because we decided for Go for fast and API and Python for good OpenCV support in OCR. We also, thanks to the Docker, we have common environment for both developers and production environments.
Okay, so benefits from the ops sides. So we don't spend time to maintaining hardware and network. We can focus on the real problems. We can now easy scale as company is growing very fast. And we also utilize a DevOps approach. It's mean, for example, if one of the microservices have some problems, so developer who create this microservice, the first person to react on this problem. Also, the developers have better understanding on our platform. They can easily create new instances, add databases, and other things. And also, as mentioned before, we just don't care about some problems with, for example, network, because if one of the instances have some problems, then platforms will take care about restart the service and back to normal working. Okay, that's all. Thank you.
Thank you.
Any question?
So do we have any questions? Oh, there we go.
Guys, thanks for that description of your environment. But you've mentioned all the pros and all the stuff you use there. But what about cons? What's bothering you the most right now? I mean, if you were to answer the question, what's the main problem of your infrastructure right now? This one in the cloud part.
I think that the most problem is that all the technologies that we use are quite new, and if some problems we have, it was hard to find some solution on the internet, so we had to do a lot of debugging during the deployment or development of that. I think the most trouble technology was Docker, since we used it like from version 1.5 or something. It was very problematic at that time. So.
We have the situation when Docker just go out mesos. And so mesos don't know about this process, but the Docker process was still alive on the slave.
Okay, thanks.
How many mesos masters do you have, and why not more or less?
Currently, we have 3 mesos masters located in different data centers and zones in Amazon. And for now, it's enough for us. I think we don't need right now more.
Hi, I have 2 questions. How are you testing it, the whole setup? For example, you have 28 microservices. If you introduce breaking changes, or don't you introduce breaking changes? And have you started from scratch, the microservices, or have you started splitting the monolith?
Okay, so I'll start with the second question. We started from implementing new features on the microservice platform, and we have not split the monolith. It was just simple to do that way.
Are you planning to split the monolith, or like do the DDD and start, I don't know?
I'm not sure about that.
Okay.
That's more a business decision. Okay, so for the platform, we are using Kitchen and Server Spec for testing the entire setup before it goes to the production. And for the microservices, they have just normal unit testing and integration testing. As for the breaking changes on the platform, We try not to introduce them right now, but when we had like in development, we do this all the time, but now it's like a stable setup. So if we want to introduce this kind of change, we have to do them compatibility, backward compatibility. So.
How much time did it took you to develop and migrate to the new infrastructure?
I think we started working in November last year, and we finished like in March this year.
Well, but basically we don't migrate because it's like separated thing right now, because part of the functionality of our service is working in microservices, but still the core of application is running on the current infrastructure.
Okay, so what are the plans? So do you plan to move everything to this new infrastructure, or you plan to keep it like that?
Okay, so the current plan is that we want to migrate away from the dedicated servers. So we decided to do an intermediate step by migrating the stack we have on the dedicated server directly to the cloud, and with the all Linux, Apache, MySQL, PHP stack, and then maybe somehow to merge these two Amazon-based infrastructures.
Okay, thanks.
Oh, they already answered my question. Sorry, it was just two of you was working on this migration thing?
From platform side, yeah.
Okay, thank you.
You guys are with the operations team? Your operations or development side of the house?
I'm both. Paweł is ops.
I'm ops.
There was some over here.
For the Docker, you are using ECS, or there are just simple EC2 machines and you are doing the Docker stuff on your own?
Yeah, we're using EC2 machines with Mesos slaves, and we run Docker on them.
So we are not using native Amazon Elastic container service, no?
We didn't want to do a vendor lock-in for Amazon, so just in case we have any problems with Amazon, we can just run away from it.
Any more questions? Oh.
How often you do a release to code to the production?
Depends if you ask about platform or microservices.
Both.
For microservices, when it's 30 seconds, the deploy is like 100 times a day. Depends on how much work the developers do about the microservice. About the platform, I don't know, because we have this immutability, so the deploys are longer than traditional provisioning. So sometimes it takes about a day to reprovision like entire Mesos cluster. So it's like you try to gather a few changes, so not to do it too often, because it's very long process right now. That's not a bad thing, I think.
Do we have more questions?
Regarding the bare metals, you didn't thought about running the Ansible from inside the network where the bare metals were? So just to skip the problems with the networking?
Well, basically, we're running Ansible from inside from jump host, which is located in the same data center, but dedicated servers with, well, basically it's chip provider, so the network stability is not always good.
So maybe changing the provider.
Well, yeah, but
Basically,
so many servers right now can be hard, right?
I've worked with several setups on Ansible, and basically there is no difference if you have the proper network between bare metals or cloud services. So basically, I think there was some problem with the architecture itself instead of problems with the networking itself.
Well, okay, maybe I'll explain something, because our provider don't give us proper isolated private network with layer 2. We need to build our own. We are using gray tunnels and beard to OSPF routing. And probably with this solution, that's why we have these problems, right? Because it's tuned tunnels.
So basically, there was no possibility to close the network, close the burst systems inside the virtual private network, and then go outside with the systems which you want to go outside, right?
Well, yes, but generally we isolated everything using IP tables and nice framework called Firm. So it's isolated, basically.
Okay.
So there was one question over there, but do we have anyone here? Because I would like to optimize my moving path. Okay. We shall see.
You've mentioned alerting. Do you have some sort of automatic rolling back to previous well-known and working version when some of contract is broken?
Currently now, it's only a notification for a developer to react, and it's on him to whether he rolls back the commits he made or just click on marathon to switch to previous version. So it's not automatic.
Okay, thanks. And the second question, you said that the whole deploy took 30 seconds. You mean from the merging to master to live code on production with unit tests and whole building and everything, or just deploying after the build?
The entire process. So when the developer merge, then it takes about 30 seconds for this code to arrive on production servers.
Do we have some more questions? Come on, I can move over there.
Did you try the other frameworks like Kubernetes, Nomad, or Docker Swarm before playing with Mesos?
I have played with Nomad like some time ago, but it was not a stable solution back then. Mesos was, so we choose Mesos. We haven't tried Kubernetes.
We have also short time when we was trying Swarm.
Swarm was also not available at the time we were doing this.
I bet you like this answer. Okay, any more questions? We still have some time.
You mentioned that you're using InfluxDB. Is it stable for you? So do you have any bad experiences with that?
Okay, so first we have single instance of InfluxDB because we was not setting up clustering. After that, we set up cluster, and no, cluster source was not too stable because we have a lot of data because we generally start to move all metrics also from the current infrastructure. Then Influx data was changed to politics, and in new version, cluster solution will be it will be not free. So right now we back to the single instance, and yeah, we'll be thinking what to do in next steps. But as a single instance, is very stable.
Okay, thanks.